Cool. Oh, God. Sorry. This is much louder in my ear than I think it is. Am I talking too loud? Oh, okay. I'm Camille. You can find me at FulgentF on Twitter. Don't think too hard about the name. It's very random. My slides will be here, but they will also be on Twitter. And this is the geography for web maps. It was the good, the bad, and the stuff you can forget about web maps, but realistically, it's probably an intro to Neogeography. And I will explain what that is in a second. I'm a developer at Mapbox. I make software and tools for people to make custom maps for web and mobile. Most of our work, we release open source. If you go to the Mapbox GitHub, you will find a bunch of public repos, and if you're interested in what I'm talking about, you should clone them and submit pull requests and get in there. It's really fun. I also teach people about maps at Maptime San Francisco. I started Maptime. It's a weekly meetup, and I started it about a year ago with some friends because we didn't know anything about maps. And we were working at a cartography studio and didn't know how anything worked. Turns out a lot of other people don't know how maps work and are also interested in learning, and we are now in 13 cities, and we have to enforce a wait list at all of our meetups because we just can't fit that many people in a room. But so why, oh, and that's really cool. You can find it at github.com/maptime, and we're at maptime.io. If anyone's interested in starting a Maptime Oslo after hearing this, come talk to me. But otherwise, we have a lot of resources in the GitHub for like starting your own chapter. But why are so many people interested in this? And I think partially it's because representation is really important. If they say history is written by the victors, then maps are made by the people who have the money, the time, or the data, or the influence to publish them. If you're a Russian user of Google Maps right now, you will see the Crimean Peninsula is like a part of Russia. But if you're a Ukrainian user and you look at the same map, you won't see that border. You'll just see it as part of Ukraine. And so you shouldn't let a large provider of maps dictate what your world looks like. You should be able to make your own map and put your own political boundaries where you think they should be. And also, you should be able to make them beautiful. You should be able to make it look however you want with whatever boundaries you want. This is a map made by one of our designers at Mapbox. This is another map with the exact same data set. It's from OpenStreetMap. It's a curated set called Mapbox Streets. That's kind of like some of the more relevant features in OpenStreetMap, and less of the trivial ones. Like people will put everything in there. They'll put like, this is where there's a post office box, or this is a parking meter. So we've kind of curated out some of the more relevant pieces for people to make maps like this, or this. This is another fun one made with GPX tracks by Eric Fisher. He does some really intense data visualizations, mostly in C, but you can find, it's interesting work. You should check it out. And then this is also made by our designers. It's of Mapbox Outdoors. It's elevation and like topography, really high quality. And so you can do all this stuff with OpenStreetMap data. And OpenStreetMap is like a Wikipedia of maps. How many people have heard of it or have used it? Yes, awesome. This is from State of the Map US in April. We had 500 people there. This is the most we've ever had for a map, like a OSM event. The community is huge and it's growing. Obviously, a lot of you are part of it. You can like watch people editing it in real time, which is super cool. The data is just improving every single day. This is the X-ray view of data in Tilemill, which is one of our mapping tools, where you can just see, it's just like everything that you can possibly see. And this is zooming into Oslo. And so you can just kind of pick and choose from this what you want. We also do routing with it. This is from our Smart Directions API, where we are routing scooters, like electric scooters, around hills and away from freeways and streets with speed limits over like 45 miles an hour, because they're just not powerful enough to go on them. So you can use this data to make really safe directions for scooters, or you can do it for cycling. If you want to avoid hills, or if you're a marathon runner who needs to train on hills, you can route yourself uphill specifically. All sorts of interesting stuff. But so people come to Maptime. A lot of them who come to Maptime are coming out of GIS. They're students who have graduated and have lost their ArcGIS licenses, or they're professionals who are looking to transition, or they're just people who are developers who want to learn how to make pretty things. And so I think that we make it a lot more fun by walking away from sort of this black box of GIS software like ArcGIS and into open source tools. And then we're kind of getting into this weird area called Neogeography, where things aren't as academically rigorous, but it's like citizen science, where people are actively contributing to OpenStreetMap and making really interesting maps and data visualizations. Right. And so we're going to talk a little bit about geodata, what to do with your data, and then some tools to work with it. I'm not going to talk about the various mapping APIs so much, like the mapping libraries, because they're really well documented and they're really well written. And so this is sort of like the oddities that you need and the kind of the gotchas in making maps and working with geospatial data. Because I feel like all of that, like the mapping libraries make a whole lot more sense once you know this. And so what is a web map? It's a map in the browser. You'd be surprised at how many people come to our meetups and don't realize this. They're looking for ArcGIS tools, they're looking for PNGs that they can just throw in a browser. But it's more interesting than that. We're working a lot with slippy maps, which is just an industry term for maps that zoom and pan and are made of tiles. And they are made of a base layer and then data, content, or feature layers. So if you're thinking about it like print maps, the base layer will be your physical printed map, and your data or content or feature layers will be like the pins and the yarn you put over your map to make relationships or put markers down. And they will be in the form of points, lines, or polygons, all of which is just a series of lat-long data. This, just to drive that point home, is some geodata or GeoJSON from a list of map times in around the world. You can see just geometry, type point, and then coordinates. And that's all this geodata is, top to bottom. Oh no. Okay, there was a slide. I don't actually remember what it was. But regardless of what your data is, it's just arrays of lat-long or long-lat coordinates. Thankfully, we've done away with degrees and points in web mapping. There was a time when you would reference everything like degrees and points. Everything's a float, and it's way better. Oh, God. Okay. There's the Substack school of presentation software, and then there's the TMCW. Is that right? Tom McWright's school. I chose big, and I'm regretting it. Oh, God. OK, this is a series of lat-longs that describe an array, or that describes a line that's the border of San Francisco. It's just a series of lat-longs. That's all I was going to say. But latitude goes from north to south. It's from the top 90 degrees to negative 90 degrees. And longitude goes from east to west. It's 0 at the prime meridian, 180 to negative 180. It's the long way. And the reason this is important is because long lat is xy. Unfortunately, this isn't standardized. And so you'll see some places that it's yx. And this is important because sometimes you just have to flip things. Not all of the APIs that are out there are consistent. But GeoJSON is. So you should use GeoJSON. If you're ever wondering what you should use for web maps, that's it. And it's just JSON with more stuff. It supports points, lines, and polygons. TopoJSON is also a good bet because you can use topology, which is instead of keeping a polygon for both Russia and Mongolia, you just keep the relationship between the two countries. So you can do, this is a visualization where no country that shares a border with another country will be the same color. And so you can use logic like that. And it's also significantly smaller. Topology is significantly smaller than GeoJSON, but even, this is kind of cut off, but even Mr. Bostock, who wrote it, says that you shouldn't necessarily use it unless you have to. So it's there, but maybe just stick to GeoJSON. Another cool thing, if you throw a GeoJSON file into GitHub, it will make this automatically. And it will also diff, so if you change your data over time, you can create time series. And so people are doing really interesting stuff with adding, faking times of commits in order to create time series visualizations of like when counties were delineated, or like when states were added in the United States. And so while we're talking about this, we're going to go to Null Island, which exists on pretty much every single map ever, so it must be a real place, because it's where your null values go. Let's see if I can actually see that. See, it's this little place off the coast of Africa where if you see it and you see it in your data, you probably need to clean it up. So what do you do with this data once you have it? If you want something that just looks like this, like markers on a map, and you don't want to deal with like making the map, or you're not interested in like the actual the data that underlies it, then you can commit your GeoJSON to GitHub, and it looks like that. You can go to Mapbox.com, you can create an account, you can open up our editor, and then you can just drag and drop GeoJSON or a KML file, or I think even shape files in GPX, and and then your metadata will become the marker labels. Or you can use a mapping library like Leaflet.js or Mapbox.js. This is Leaflet. Super wonderful and amazing. The only thing is that they have swapped the lat long for most of their for most methods that use it. So if you have to, this is one of those places where you have to flip it, and if you're not sure, just try again with different coordinates. And then Mapbox.js is just an extension of Leaflet with just a little bit of a cleaner API, especially that one that works with our map hosting. But if you want a map that looks like this, and you look at OpenStreetMap and you're just overwhelmed by how many features there are and what it looks like, and you really just want something that's clean, and you want to see parks and maybe some buildings, but you don't want to see every telephone pole that's ever been added, you need something like Tilemill. Or if you're adventurous, Tilemill 2. Tilemill 2 is what I'm currently working on. It's really interesting stuff with vector tiles. But so what you can do with Tilemill, see if I can make this a little bigger, is you can create, you can use cartocss to style all of this data. And it ships with just your basic Mapbox streets, which is a curated version of OpenStreetMap data. And you can say, okay, I want the water to be orange. And it's done. And you can also go through here and you can set scale ranks, which means that certain features will show up at certain zoom levels. So if you don't want to see, for instance, like country labels until you get to zoom level 5, you can do that. And then you can save it and you can export it up to Mapbox. But so why do you need an editor like this if you can just use CSS or cartocss? Because maps are more complicated than websites. At first they were really static. In order to zoom or pan, like the original MapQuest maps, you had to refresh or reload your entire page. Oh. All right, there was a caption for this. I was really afraid of this. But this is in 2005, we got something called the tile. The tile is a 256 by 256 square of data. It's a raster or a PNG, and it's totally standardized across almost every single provider. Like if you go to a Google Maps map, or a Bing map, or a Mapbox map, or OpenStreetMap map. And if you find like the coordinate for a specific place, you can find it will be the same location. The data will be different because the data is different for every provider, but it will be you'll be able to find the same place. And so at zoom level 0, you will always see this. You will always see this square of the entire world. And at zoom level 1, you will always see 4 tiles that look like this. And it's a quad tree, so it's going to get chopped up into quarters as you keep going down, increasing the number of tiles increasing exponentially. So when you get to zoom 17, you have theoretically 17 billion tiles for the entire world. But we don't actually store all of those because we've gotten to the point where we're clever enough to say, this is the ocean, it's a blue tile, all tiles that are in the ocean, or all places in the ocean will reference a single blue tile. And so we're not actually storing, thankfully, 17 billion or rendering 17 billion tiles, but that's just like the potential. And then, so this is the coordinate system. So pretty much with any API, you can access it by zoom, X, and Y. And since this is zoom level 17, you get insane numbers. And they get bigger as you go up to like zoom 22, and then most people stop there. But in order to cut the world into these squares, we need math. And so we use projections. A projection is just a way to turn a 3D object into a 2D, like a flat plane, and as flat a plane as possible. But we all use Web Mercator. Web Mercator is one of these weird things that people get really upset about. Like if you're a social geographer, you think that it's the worst thing that's ever happened because Greenland is huge and Africa is little and tiny. And this was developed by software engineers who wanted to cut the world up into squares and make quad trees of tiles. And they didn't really care about the social implications of Greenland being enormous and Africa, a country of many, many people, being tiny, or continent. Also, we're presuming that the world is a sphere because it's spherical Web Mercator, but it's not. The world is kind of oblong and it's bumpy. And so there's a lot of these weird assumptions that go into this. And it was developed 450 years ago for navigation, and we're still using it for navigation. So a lot of people find it very controversial. However, all right. But so all you really have to remember about this, I think it's really interesting. Projections are cool. People get really nerdy about this. But all you really need to remember is this number, ESPG 3875, or the number 900913, which actually spells Google, because it was the working title for the projection when Google released this. Because if you see that your data is in a projection other than this, you need to figure out a way to get it into ESPG 3875, or just start over and find a new data set. But really the only time you see this is when you're importing a source into Tilemill with your own data. You'll have an option of WGS84 or Google. And WGS84 it's a more accurate projection. It doesn't presume that the world is a sphere. It understands there's a bit of an ellipsoid shape to it, and it's got some bumps. And then, so if you select that, Tilemill will just project it into the Google projection for you. There was a time when you could have used any projection, but we no longer use WMS, we use TMS. And also, if you're willing to project anything into this sort of spherical Web Mercator, you can make really interesting non-Earth-based maps. They just will happen to be this way. This is, I think, the Andromeda Galaxy, or some really awesome image data, and you can zoom in and pan, and you can make this with Tilemill just like you would a map of the actual Earth. It's just projected into that coordinate system. But if you want to get crazy with projections, you should just go learn about D3 and D3's GeoLibrary. But back to Tilemill. Once you export your tiles, we will host them. If you want to run your own server, you can. Have fun. You will need something called Mapnik. And I'm not going to tell you how to run your own server with Mapnik, but what is really fun about it is that it's the Bob Ross of Tilemill. And it's the thing that literally paints all of the streets. And I find it, I envision it as like this little man hanging out in the back of the software, painting all of the streets down in the correct order so that when you see freeway overpasses, they're actually overlaid on top of the streets that run below them. And now we can do these really fun things where when we load a PNG, so here's Oslo, we are now rendering tiles in the browser. So you can go like this, oops, and you can see the data that underlies it, which actually is not in a lat-long coordinate system because it's already gone through Mapnik. And then you can go back just like that. And so this is how easy it is to add these to show a map with the tiles you've imported. You will get a map ID when you import your tiles into Mapbox.com, and then all you do is you set a view. And if you can notice this is that flipped XY. This is for San Francisco. Normally San Francisco is represented as negative 122.5, comma 37.75. Yeah, that. And then this is how easy it is to add GeoJSON into, oh, it's cut off. Into a map. You just say, I want a Mapbox map. Actually, let's go back because I don't think anyone can see that. You say, I want a Mapbox map. Look for the div map. Put give me these tiles, and then there will be a line that says set GeoJSON, and then your GeoJSON variable, like this. And that will give you something like this. Really easy. But wrangling your data is the hardest part, and since we want everything to be in a format that's easy to parse, if you have shapefiles, you can use ogre to ogre. If you install GDAL, and it's included in GDAL, and it's awesome. I asked friends what I should talk about, and they all said this. And then if you want to stay in node land, you don't want to, you want to just stay in this warm, friendly node universe, you can use to GeoJSON, but I think it only works with KML and GPX data. And if you want to just convert your data on the client side, you can use leaflet-omnivore. And it's as easy as that. It will just kick out your data in a form that Leaflet or Mapbox can parse. And if you really need to be converting your data and you want to be working with projections, use QGIS. Just a quick example, here's a map that I made on the plane. It's GPX data that I just used Omnivore, and then I added a D3 color range to set rides. This is me biking around San Francisco. Rides that are more recent will be in yellow, and rides that are closer to January 1st, 2013 are in red. So you can see I started a new job and started moving this way. I used to commute on this line right here. So that was super, super, super easy. Oh. Sorry? Oh, that's BART. That's the transit system. I don't know why. I was going to clean this up, but I decided it was kind of interesting. You don't see this. I actually have an example. So you can add D3 in here and make cool color scales. So if you import that same data into MB tiles or as a Mapbox tile, you don't see that weird jump over the bay. You can see that there, the little bike ride I took over there. For some reason, that's Omnivore just appends those points together, and so you get that line. But so if you import this data into Tilemill, you can export something like this, which is a ready-to-go raster that you can throw on top of any other data source. And yeah, so web cartography kind of like fits into this weird place between art and science and traditional, like the traditional GIS and geospatial analysis. If you're interested in this, in more of this, just hang out at the Mapbox website, take a look at the repos, play with Tilemill 2, play with vector data. It's really fun. Okay, thank you. Thank you.
So I know GIS stands for something geo something.
Oh.
What is it actually?
Well, that's a point of debate, I guess, and I'm not comfortable defining it as saying this is the definition of geo-information systems, but you also can call it, or like geographic information systems, but you've also, I'm going to stick with that one. I'm trying to think of other ones. We got in a big fight at Maptime once about what these are, by GIS people saying that they believe that it's a derogatory term, like it's a term that people assume isn't as descriptive as they want it to be. But I don't know. I just Wikipedia. Just don't take anything I say on this as real.
Question on Mapbox. If you do any question assumes that you can do that. I don't know. If you do any data correction on maps in Mapbox editor, do they find their way back into OpenStreetMap?
No.
Okay.
Because on the editor on Mapbox.com. Yeah, so you can't actually edit the data through Mapbox, the Mapbox editor. Well, you can add your own data. You're basically just using a set of pre-made tiles. And there's a little link at the bottom that says improve this map, and that will actually just send you to OpenStreetMap and the ID editor there. And then changes that are made there will eventually cycle back in.
How long is that cycle?
I don't know, it depends. Mapbox Streets gets released. I think we're releasing version 5 soon, and so I'm not actually sure what the pipeline is for that.
Fair enough, no worries. We should have a conference on Null Island.
There is a Maptime Null Island.
And then one question on Tilemill too, how stable is it and what's your release schedule plans for that?
Well, I just released 0.13.0 yesterday while I was here.
Good.
But I don't know. This is still, it's kind of something we're still playing with. It is stable. It doesn't accept all the sources I want it to yet. Like, you actually can't import GeoJSON into Tilemill 2 right now because there's something in Mapnik. But Tilemill 1 is great and works perfectly. But places like Stamen Design is using Tilemill 2 for all of their map development currently.
Right. Cool. It's a bit of a personal question. From a small childhood on, I love looking at maps, like real and actual maps. And when Google Maps came out, that was a huge mind blow, as I think it was for everyone. And then Apple came out with their maps, and they said, we have better designed maps. And I looked at them, you're missing all the important information. It's like all the stuff that I knew how to get around, they thought was irrelevant, and they just make really clean streets and not much context. And then Google said, well, we make it like Apple does because they know how to design stuff. Apple does not know how to design maps. What's your take on that?
That Apple doesn't know how to design maps.
Lucky we have all your tools that we can build our own maps that look the way we want. Or do you agree that this current new style of commercial mapping is actually worse than the previous generation?
Oh, I don't know if it's worse. I think that there's agendas. Most of these maps are used for routing and navigation, and so there's an emphasis on that data and those features. You want to be able to get someone from point A to point B.
Well, that's a very good point, because the old Google Maps style has comically big streets.
Yeah.
And I think that's really good to have, because that's how at least I navigate. And now they're as big as they are in proportion to everything else in the geography, and that's really bad for navigation. So I cannot.
And that's what one of the things Mapbox we do with Tilemill is when Pinterest uses our maps, and they are not looking for navigation, so they can show features that are more interesting to them and just really emphasize markers and not streets. If you notice, like on some of those designs, the streets are really downplayed.
Right.
And so it's kind of just what your use case is.
But for somebody, you could do the reverse. I could make my own maps with big streets.
Yeah.
Excellent.
Yes, you can do that.
All right. And you mentioned you're doing a meetup, and that is a growing meetup. How did you get into that?
I was working at Statement Design, and I wasn't making maps, and I wasn't actually doing much that was technical. And so a friend of mine and I went to State of the Map, and we were like, this is the best thing we've ever seen. How do we do this? And it started out as 2 of us sitting in a room on Wednesday nights, and now it's 13 cities.
Wow.
So it's just kind of like one of these things that kind of got away with us. But you learn best by teaching, and so it's not only have I learned a lot from like the GIS people who come, but like really wonderful developers started coming to the meetup and like running lectures and workshops. And so you should also start one here.
Yeah, so if I was going to open one in Oslo, what should I do? Where do I go?
You should go to the GitHub, or you should talk to me, or you should just say, I want to just copy-paste our mission statement into a website somewhere and say that you're doing this.
All right. Okay, that's all the questions we have. Thank you.